Hi again. I hope you liked the explanation of my project and the work that I did. And again, I'm Ankit, enrollment number A16 CSE 103, and I've been working with HEIG in collaboration with Net Guardians, who procured the financial data that I work with. And it's been a privilege and a pleasure to work here. And thank you for watching my video. Hi. So I'll be talking about my project that is recurrent neural networks for fraud detection. So I had the opportunity to work in Switzerland, the financial capital of the world, which on financial data here from the banks of Switzerland to actually see for myself and get around on results. So, what is fraud? So, fraud is a specific topic of anomaly detection in our case. So, they're extremely rare events to the point that there was imbalance in our data set for 99 to 1%. So, to be honest, that's a very huge imbalance that we are seeing. So in this project, I've systematically taken into account different kinds of algorithms and approaches, going from statistical approaches to vanilla machine learning approaches, and then to our primary algorithm, which is the long short-term memory, the LSTM. And even after that, I took the liberty to create a bidirectional LSTM to go for it. So now we look at the statistical approach here taken in the project. So this approach was taken by my predecessor Julia Moschini, and she used statistical approaches like RMA model to predict outliers in the data in order to check out where exactly the fraud lies, and she took into account only the timestamps. So that incorporates or inculcates very less number of factors when it comes to the data set, although I cannot discuss freely about it because of non-disclosure agreement, but there were many. So it was a very small part to go in, so I could broaden the horizons. So that's why I wanted to include different methods here. So I chose for machine learning models to be a better alternative. So I wouldn't bore you with the model details exactly or how it works. So we'll move past that on towards the machine learning and over the statistical approach. So what is my take on this? So what I think is RMA models are pretty good, but they're fundamentally different from machine learning models, which are usually, for example, machine learning models have an architecture which is made to make prediction or see pattern within data, which is something that a statistical model duly lacks and fundamentally lacks too. So also all of the companies and all of the industries in the world are taking in the machine learning into their hands. So it is only fair that we go to that level as well, if we want to predict a lot of data altogether and accurately as well. So this is something that I think machine learning could do better than normal vanilla algorithms, which employs statistical methods. And there is an imbalance of data set so huge that it is also problematic for basic machine learning algorithms to work properly. So that's why we used a primary algorithm, that is long short-term memory. So we'll see how the performance was done and how it was evaluated. Onto the next slide. So machine learning approaches here was SVC, support vector classifier. So I won't exactly go into depth and explain all this. So we used SVC for categorization of binary data, KNN for clustering the data here and there, and then decision tree was also used, which takes in simple learning decision rules in front from the training data. Then logistic regression, and unlike popular belief, it can also be used for binary classification problems, which we have done so in our data set. So it worked pretty good. Now, as you look towards the output or and the results that we get, we see the training and the testing, the curve is pretty high, even reaches about 0.96 as well. That is the AUC score. So it is pretty high, but it leads to a very huge misclassification when it comes to the confusion matrix. And this is because of the problem called the vanishing gradients problem, and it occurs because the partial derivative of the weight that is to be updated in the weight vector is so small that the model stops learning out of the information altogether. And this is very problematic because we are dealing with only 1% data, which is the fraud one, and we want to extrapolate as much information as we possibly can. So this is the problematic situation in which we are stuck while we use vanilla algorithms such as these. So while they perform very highly in the performance and training and testing, the misclassification, there is a huge misclassification amongst the algorithm, which creates a very huge problem for giving out proper results. So the same can be said about decision tree, KNN, support vector classifier, and even. But as you can see, now we see the notable conclusions here that the average PR score is about 0.64. So there's an overwhelming issue of misclassification, which is a very huge problem here for the vanilla algorithms that we thought could work. So apparently they didn't. So that was a bit problematic, and so I decided to move on towards the primary approach that was needed to be taken. It was the long short term memory, LSTM. So the primary and principal approach for extrapolating the maximum amount of information for interpreting the class labels with the highest accuracy, and it works like a conveyor belt. So information can also go throughout the cell unchanged. So that is how the data is regulated by gates. So right, so we got the multiple gates that that comprise the long short term memory. So we got the input gates, which take into account all the information to and fro from a LSTM. So it is run, so all the data is squashed and made into a candidate layer, which is then updated in the hidden state and the cell state, and all of this is in tandem with multiple units of LSTM. In our case, we used about 128, because after behind that, then we have bidirectional LSTMs. So because I couldn't get enough information extrapolation out of the previous LSTMs, I went on to incorporate a bidirectional LSTM, which has a forward layer, a backward layer, and all of the output goes through a tanh activation function, which squashes the probability values for the label prediction into 0 and 1, henceforth giving us a very ideal output in which we can tell for the label what is the probability of it being actually true. So this is how it works. It takes in the forward layer and it runs through in one session a complete forward input, and then in the backward layer the data set is run backwards. So they run in parallel, and the output is then put down to a tanh layer, and then a dense layer gives out the probability values for the corresponding the class value. And then I set a threshold depending on how much it varies, and then I can do a class prediction accordingly, and even the threshold is variable. Right, so moving on. Then we see the observations for LSTM. So this was the basic. As we moved on to this part, we see we get a 60% accuracy rate, and this also acts as seasonality hits to the LSTM models. So this can be reinforced. The observations of this LSTM can be reinforced with the output of probability values for the LSTM, which is our primary algorithm, in order to reinforce our results and to double check the values being fraud or not. So now the LSTM that I've taken in actually does predict the values, I can see. So it is giving the class and the predicted probability for its occurrence. So see, for class 1 it is 0.04, and even for other zero classes it actually tends to get close to that value as well. So there is a overlap of probability values, which leads to misclassification again, and also the probability values drop down to negative values, although the accuracy for this is pretty high, which pretty much goes down to about 99%. So but nevertheless the non-fraud data itself is 99%, so there's still that 1% left, which was filling out the gap. So now you can see it is a distribution of probability values for all the prediction labels. So as you can see, it varies a lot. There is no fixed pattern over the prediction output, so this puts me in a very precarious spot, and this puts the LSTM down, and it hits a rock wall on that. So I implemented a bidirectional LSTM after that to fix that problem. So now we take a look at that. So now we get an 50 units each LSTM feed forward and backward layer with an accuracy of 99.86%. So that less than 1% part that we were talking about is actually being utilized here. So it might go more than 99%, but now we are seeing that less than 1% part is actually being predicted properly. So what I did was I took the class label and the predictions out, and then I averaged it out to set the threshold value, which decides for on the basis of the prediction should it go to a class label 0 or class label 1. And as you can see, we got for 0 and 1 segregated properly, no values dips down to negative, and I run it through a TANH activation layer. So that actually came in really handy, and it was pretty helpful. So we finally have a proper working bidirectional LSTM, which predicts the probability of the class label being fraud and non-fraud. And here are final thoughts and conclusions. As you can see, the model and accuracy, RMA was pretty good. Even the vanilla algorithms had a good AUC score, but we saw the problem with them was an overwhelming imbalance in the data set, which led to misclassification. Then the baseline regressor was 40%, and the LSTM regressor for behavioral patterns in expenditure was 67. Then the linear LSTM went down to 99.2, and the bidirectional LSTM saves in more context and information to give us the model that outperforms all the other models that we have taken into account with a 99.7% accuracy. So that was my project here, and see you again, guys. Ciao. Thank you very much. Hi again. I hope you liked the explanation of my project and the work that I did. And again, I am Ankit, enrollment number A16 CSE 103, and I've been working with HEIG in collaboration with NetGuardians, who procured the financial data that I worked with, and it's been a privilege and a pleasure to work here, and thank you for watching my video.